Hi, this is Wes Simpson with another edition of the Summer Sessions on Media over IP, brought to you by AIMS and the VSF. With me today is Andreas Hildebrand, who is Technology Evangelist from Ravenna, and he is going to be giving us an introduction to IPMX. Welcome, Andreas.
Okay, thank you, Wes, for the introduction. Let's jump right into the topic of today's session. It's the introduction to IPMX. So, if we look at a typical ProAV situation these days, a stadium, there are quite a lot of different sources and destinations where you want to feed audio and video, of course. Usually they are all different. They might have their proprietary connections. They may or may not share, but quite often there's the need to actually share some content. So what you usually have is some sort of a proprietary infrastructure with point-to-point connections and cross-point switches somewhere in the back and bridges between various systems. And now, of course, networks come into game, and we see quite a number of benefits through network-based transport of audio, video, material. We don't have to discuss any of these individual points you see on the screen. I think this is just a given from years of experience we have with the AV distribution based on network technology. So if we look at the current AV over IP landscape in ProAV, we mostly see some proprietary or let's say marketing standards out there. So we have NDI, SDVoE, we have the all popular Dante system out there, and we also have HDCP, which not quite nice, quite a networking approach, but it can at least transport network signals through those point-to-point destinations. On the other side, we have standards running in the broadcast industry or developed by the broadcast industry and being used by the broadcast industry for quite some time, like SMPTE ST 2110, and from NMOS we have NMOS specifications. AES has the AES 67, and there are much more standards which are being used to compose systems on the broadcast side of things. So if we are now looking into how we could apply those standards for the ProAV side of things, we grab those ST2110 and NMOS and the others, and we'll have to add a few more which provide essential functionality in the ProAV world. Usually it's about control, HDCP, copy protection, security, and so on. And we are squeezing them all together into what we call IPMX. So actually, what is IPMX? IPMX is the Internet Protocol Media Experience. Here's the final logo for that. IPMX basically defines a set of common and open protocols, which are mostly standard-based for, and this is very important, interoperability over IP for the ProAV industry. The specifications are based, of course, of what we have on the broadcast side of things, but we also would enhance those specifications by allowing transport of compressed audio and video, of course, uncompressed as well, wherever it's required or possible. And we also need to transport metadata over those networks. And as mentioned already, IPMX includes important provisions for control, connection management, copy protection, and security. And all of this is based on the AIMS roadmap for interoperability or for interoperable media over IP. So question is, what or who is AIMS and why it is important? Well, AIMS is an abbreviation for Alliance of IP Media Solutions, which is a non-profit trade alliance, which is focused on fostering the adoption of a set or one set of common open standard-based protocols for interoperability over IP in the media, entertainment, professional audio, video, and historically, of course, originating from the broadcast side of things. So that is AIMS, and AIMS is not quite, a few companies coming together. It's a very, very strong alliance with more than 100 companies and also broadcasting organizations which are gathering under the hoods of AIMS with technical marketing work groups and defining which standards can be used and utilized in such an roadmap for interoperable IP. So this roadmap aims is updating every now and then. The latest official update is from July 2019. We expect one of the next updates coming in soon. This particular COVID situation also had some impact, of course, on this kind of work. But we are based on this particular roadmap, which is starting with the traditional SDI over IP transport. This is a standard called SMPTE ST 2022-6. We have a well-established audio over IP standard, AES67, should be known by everyone by now. Then this suite of standards under the ST2110 hood is there to transport video, audio, and metadata elements over IP. And the latest addition to this roadmap was the JTNM Technical Recommendation 1001. JTMN is the Joint Task Force on Network Media, which is backed by AIMS, EBU, VSF, and other important organizations. And under JTNM TR 1001, there are important definitions and protocol suggestions for device discovery, network control, registration, connection management, and also definitions for critical system parameters. So this is a well proven roadmap where most of the broadcast operations are based upon. And now we are suggesting to enhance this, to build on this roadmap, enhance this roadmap for the application to the ProAV industry. As you can see, AES67 and SMPTE ST 2110 are still part of that. And for the ProAV standards side of things, of ProAV applications, further standards and specifications are added to that roadmap, which, for example, is a standard under the 2110 hood covering video compression. We also, of course, are based on the ST 2059 standard for the whole timing and synchronization stuff, which is required. There's a new standard in the works, which most probably will cover advanced or enhanced control, which is necessary for the a ProAV side of things. Discovery registration management will be added to the roadmap, as well as further, well, mostly optional, but very important functionalities like audio compression, HDCP, general purpose I/O, and further down the road, security, authentication, encryption, which are very, very important functions basically in the ProAV side of things. So that is what we propose as an extension to the existing AIMS roadmap, to build a roadmap for ProAV or IPMX. All right, so let's have a very quick look at the relevant standards, the rock bottom, the solid standards, which are the foundation of the IPMX environment. So AES67, I mentioned that, defines high performance audio over IP interoperability. SMPTE 2110, very important for the elementary essence transport of anything which goes with the video. SMPTE 2059, which is basically referring back to the well-known precision time protocol, IEEE 1588 protocol for all things related to timing and synchronization, and the suite of NMOS specifications, which cover everything above transport and synchronization, like operational and management functionalities. So a very, very quick look into these different standards. I'm not going to do any technical deep dive. There are other webinars and sessions which are covering this. So let's just have a quick introductory look at these relevant standards. AES67 basically is there because back in 2010, when we started the work in the AES task group, we identified a number of existing audio over IP technologies like QLAN Live via Ravenna, Wheatnet, Dante, and there might be even more out there. They are all based on IP, so they all utilize IP as their transport mechanism. However, the problem is they don't talk to each other beyond using IP. There are so many differences and incompatibilities that there was just no way to directly exchange any audio content between them. Well, not quite true for LiveWire and Ravenna. As you can see, they were able to natively talk to each other back in 2012, even before the release of AES-67, just because those companies sat together and found a way to make things interoperable without having to go through analog or digital audio connections. But finally, the AES came out with their AES-67 standard, which is a set of guidelines which is being put on top of the existing operational principles. And if those definitions would have been implemented and fulfilled, then all these solutions can natively talk to each other without leaving the IP domain. And actually, this has happened, as we all know by now. The adoption rate of AES-67 was very, very fast. So AES-67 is the AOIP interoperability standard. Now, for those curious what it needs to write such a standard, we need a number of functional technology blocks where we need definitions to be in place, and AES-67 identified those functional blocks and has put out some mandatory requirements for each of those functional blocks, which altogether compose the AES-67 standard and which can now be, or actually are now being supported by all other audio over IP technologies out there. So not going into further detail, as I explained earlier. If you want to know more about AES-67, there's the URL where you can download the standard and certain other documentation about that. Now, the next important standard is the SMPTE ST 2110 suite of standards. 2110 basically covers the transport, synchronization of separate elementary essence streams. That means that audio, video, and ancillary data are being transported as individual, separated essence streams. So in contrast to transporting a multiplex combined SDI signal. And of course, we are talking about managed IP networks, not the wide internet. So anything where you have control or where the operators or administration has control about the network, but it's not limited to any speed. So whenever speeds, new speeds are becoming publicly available, they can immediately be used without having to change the standard. So, and the whole standard is, of course, for professional applications like production playout, producing live shows, but also other professional media applications. So a quick look into the differences between, the combined SDI transport into one stream. This is the bundled approach. That's when we transport all the audio video metadata press that into one stream and transport that one stream as a flow of packets across the internet. So everything is there, audio video metadata, and everything is locked in place because it's just encapsulating the content of an SDI signal into IP. In contrast, we have the essence-based transport, where you can see that the individual essences are flowing across the network as individual streams with their individual IP addresses. And the challenge, of course, is how do we keep everything synchronized? And that is done employing the precision time protocol for everything, timing, and synchronization. So here's another illustration. This is the bundled approach, which is defined in the SMPTE ST 2022-6 standard, where you have the SDI, the content of an SDI signal, like the active image raster, the hang and wang auxiliary data space, which also contains the audio, everything encapsulated into one stream. That is quite often used for contribution or distribution of signals which are readily produced. In contrast, we have the essence-based approach, where we separate all these individual essences from each other and transport active video, audio, and metadata across the network using individual streams. Now, why would we do this? That becomes immediately clear if we look at a typical application picture. Let's say we have an environment where an audio processing device needs access to the audio. Now with the 2022-6, the bundled approach, that processor has to receive the full SDI stream, the full multiplex streams, has to depacketize and de-embed the audio signals, just do the audio processing, re-embed, and packetize back into a full loaded SDI IP stream. This is the situation with the 2022-6. With 2110, We have these individual essence streams already separated from each other on the network, so the audio processor only has to receive the audio packets, and it does not have to do the embedding, de-embedding, or de-embedding, re-embedding, and then it can do the audio processing and put back a processed audio stream on the network without even having to touch or receive the related video or data streams. By the way, these graphics, Wes, thanks for those. Yep, and they are nicely describing the situation between these two fundamental standards. So here's an illustration of a typical overall network picture, simplified, but it you easily get the point of the advantage of 2110 in a production situation. Now you have the SDI source material, video and stereo audio. ST2110 sender would typically send them off into separate streams to the IP network. They can be received anywhere on the network. And of course, the original SDI signal can be recomposed from the timing information and the individual metadata streams. Now, this wouldn't make any sense, any advantageous sense in terms of 2110, but it comes immediately into game if we look at receivers which only need particular information, let's say an audio mixing console or a subtitle processor or whatever. They can just receive those data streams which are relevant for their processing tasks. And of course, on the contribution side as well, a camera does not have to feed out a full SDI stream anymore. It can just feed video and metadata into the network, as well as microphones just have to provide the audio signals into the network, and then they are all available everywhere. And through PTP, we make sure that the timing among the relationship among all these signals is very precise. So, of course, 2110 is not just one big standard, it's a suite of standards, and I'm not going into the details, just giving you the names and the numbers for them. We have a -10 document, so SMPTE ST 2110-10, which covers system timing definitions. We have -20, which tells you how to load uncompressed active video into packets, and only the video, no audio, no metadata. We have the -21 standard, which covers traffic shaping of those huge amounts of uncompressed video so that you don't overload the network or any subsequent buffering or receiving stages. There's the -22 standard, which covers how to put compressed constant bitrate compressed video into IP packets without specifying the particular codec. So a number of constant bitrate codecs can actually be used with -22. Then on the audio side, we have the -30 document, which covers linear PCM audio. That's basically fully in line with what AES67 has already defined. We have some constraints, but they are not that relevant that we can't say we have a full compatibility with AES67. We have another standard, the -31, which covers audio. Now, since AES67 only has linear PCM audio, so 16, 24-bit linear audio, we have the needs quite often in production scenarios where we would need a full AES3 bit transparency on the network so that we can send not just the L24 audio bits with it, but also the PCUV bits and the block and frame start bits as being defined by AES EBU audio or AES3 audio. We call this the AM824 format, which, by the way, was taken from the Ravenna specification and is being transformed into the -31 SMPTE 2110 standard. Of course, there's a standard which covers the SDI ancillary data, those portions of data which do not cover audio, but just any metadata on the video or subtitling, whatever is distributed in the Wang and Hank data spaces, except for the audio. That's the -30 or -31 standard, which is then being used. And guess what? There are quite a lot of more standards currently in the works, which will come out over the next month, and we'll see more enhancements coming there. So that's an overview on the suite of 2110 documents. If you want to learn more, there's a nice FAQ site on the SMPTE.org website, and they'll give you much more answers to questions you may have at this point in time. So, but now we have covered the transport. What else is required for a full working system? Well, we need to establish connections and we need to have control in place. This apparently is not covered by 2110 nor AES67. So that's where actually NMOS comes into game. AMA is another organization. It's the Advanced Media Workflow Association. It's not a standardization organization like AES or SMPTE, But under the hood of AMBA, there are people working together, defining very, very important specifications. And that's the set of NMOS specifications, the networked media open specifications, which basically is a growing family of definitions which are complementary and coexist, with the transport specifications like 2110 or AS67. So what specifications do we have as of today, which are important for IPMX? We have ISO 4, which covers discovery and registration. So basically that standard describes how to enumerate and register all available system resources, devices, streams, and so on. We have ISO 5, which is connection management. That covers how to actually connect available streams to certain receiving endpoints. We have ISO 6, network control. This is whenever you need to configure your network resources in order to cope with the huge amount of video data. So it's basically describing how to configuring the routing tables inside the switches. Then we have ISO 7, which is event and tally specification. So you can communicate, like, let's say, key press or current status or RS-232 signal states and state changes among different devices. Another important standard is ISO 8, which gives you the ability to map audio channels contained in a -30 or -31 IP audio stream to certain inputs or outputs on your particular device. So it's an internal audio mapping from channels to discrete outputs, or from discrete inputs to channels of a sender flow. And then there's much more in the works. And if you're curious what the current status is of NMOS and what else is in the works, just another website I can recommend. It's nmos.tv, where you have an overview on all available NMOS specifications. So as a summary for 2110 and NMOS, we can say that ST2110 covers everything related to synchronization, essence, stream transport, and so on. And NMOS is sitting above 2110, providing open interfaces and functionality for registration, subscription, control, channel routing, and so on. And this layered module actually offers a very genuine value proposition to the IPMX side of things, because now with the underlying NMOS support and its open nature, together with the RESTful API, which is part of the NMOS specification, manufacturers and AV integrators now have the creative power to actually build their own controls and enhance and design the systems for particular integration purposes. So both layers are quite open and provide abilities to further define and architecture those systems. Okay, so let's jump back just for this particular slide, looking at 2110 and its first use. Apparently it was broadcast. And in broadcast, usually you have some requirements. Highest quality is required. That is why we used uncompressed active video and audio and no compression so far. Lowest latency is absolutely required when you do broadcast production, and it needs to be source synchronous as well. Highest reliability, we just can't afford any dropouts, any missing frames. So redundancy has even designed into the whole 2110 architecture. And of course, the whole thing has a composable or layered architecture, as just shown. Now, IPMX is built on these, I would say, battle-tested operation for the broadcast industry. And that's important for two reasons. Basically, all these elements are already proven by an industry which is renowned for exacting demands. And contributions were also made not just by broadcast manufacturers and broadcasting companies, but also network providers like network gear providers like Cisco, Arista, Mellanox, and others. Now, in all these specifications are, built through a standardization process. Although standardization usually takes longer than anything I just define on my own, I would say a proprietary solution. It's a democratic process. So it's an open process. Everybody can contribute. And at the end, it builds a trusted platform And on this trusted platform, we even have already seen the launching of actually working products like stuff from AJ Video System, Magnica Matrox, and also Ross Video, which could all be seen at ISE 2020 earlier this year. But by the way, which by the way was the last public show which happened, and I'm hope to see more shows coming up. Maybe we have a chance together. Yes, I don't know, New York. We'll see. All right. So, but for the ProAV side, building on these ruggedized and rock bottom functionalities, we need a bit more. First of all, we need the ability to trade off of any of these uncompromised, requirements from broadcast side of things. Certain areas where we don't need that high quality, or where we don't have the bandwidth available, or which we go with a more relaxed, could go with a more relaxed latency in order to accept lower possibilities we have on a certain network. So we need to add, or need to be able to go with flexible trade-offs for the ProAV application. And then, of course, we need, as mentioned earlier, more functionality like HDCP and other control means usually provided by HDMI, and also other means. So this is what we need for the IPMX side of things. And what we essentially do with the IPMX side of things, we take the ST2110 and the NMOS functionalities which are available and add the compression for audio and video to it, compression through things like the 2110-22 transport standard and codecs like JPEG XS, but also J2K or VC2 or others could work. We need to add control, usually found with the HDMI connectivity. They most likely will be added either as part of the NMOS specification or NMOS suite of standards, a suite of specifications, or through the 2110-41 standard, which is covering fast metadata transport. It's in the works right now, and we could expect to see something emerging maybe beginning of next year in this area. Security is very, very important. I already mentioned HDCP. We have currently a discussion going on with the HDCP group. We have provided a requirement document to them, a specification document, and we will soon see a written specification for the HDCP requirements or the HDCP functionality over IP in the context of IPMX. And of course, finally, while we have a very, 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 very sophisticated timing system in place with ST2059, there are quite a number of use cases in ProAV where we actually don't need this very, very precise synchronization and timing, which on one side also needs sophisticated PTP gear like grandmasters, sometimes even GPS reference grandmasters, or PTP-aware network infrastructures like boundary clocks, transparent clocks, and so on. And there are quite a number of use cases where we just don't need that particular precision inside the network or at the receiving ends. And so we will add some definitions for a more relaxed timing specification in constrained or share networks as well. So that all will go from the root of 2110 and NMOS into IPMX, and most of this is either already under definition, already there, or will be addressed very, very shortly as part of the AIMS roadmap you have seen in the beginning. So let's take it to a summary. IPMX, the IP media experience, finally defines a set of common open standards-based protocols for interoperability over IP for the ProAV industry. Its emphasis is on open, of course. Then we add this with provisions for control and connection management and protection security. And yeah, that's coming up now. It's based on the open and proven standards, which are already in use in the broadcast industry, and most important, which are supported by a non-profit industry alliance. All this is going to be built into IPMX. And we think that because we are building an open specifications that manufacturers have the freedom, to make their own decisions by emphasizing or enhancing one or the other system functionality and add to particular, systems, applications, particular use cases. So, and I find a nice quote, which I want to close the presentation with for today. Let me just read it here. Overall, IPMX introduction is intended to move the AAV industry forward with a flexible and future-proof way to ensure, and that's important, interoperability for AV over IP products and systems, along with the framework for, again, important, open, easy to deploy solutions for AV integrators. That's a quote from David Chiappini, who is from Matrox and is also the chairman of the ProAV technical group in Ames. So this is quite bringing my overview presentation on IPMX to an end. If you want to dig deeper into any of the underlying principle, concepts, specifications, standards, here's a list of valuable URLs to turn to. I also want to point out the last one, the Ravenna URL. We have a huge resources section which covers not just the Ravenna, but also AES67, of course, 2110, where you find quite a lot of references, white papers, and the alike. And of course, Ames and SMPTE also provide further information on this topic. So that brings the presentation to an end. Wes, thank you, and I guess we may have some minutes for a further chat.
Andreas, thanks. That was a great presentation. I did have a couple questions.
Sure.
First of all, with respect to HDMI and specifically HDCP, where does the industry stand with that? And if people want to get involved, how would they take care of that?
Right. So first of all, it's the ProAV task group from Ames, which is engaging in this topic. So they have written a proposal or a specification, we would say so, how HDCP can be adopted for IP in the context of 2110 transport. And they are currently in discussion with the HDCP organization on the adoption of the requirements for IP-based transfer. So yeah, Ames technical work group, the ProAV task group or technical work group would be the right place to engage.
Great. And if somebody wanted to get involved with IPMX today, in other words, if they wanted to start, building products, designing products, or if they wanted to even deploy them, where do we stand in the industry?
Right. So I guess it's important to differentiate between, designing and building products for IPMX and already using them, so getting IPMX ready products. As you learned from the Ames roadmap, IPMX is still in the flow, so it's not everything which is being defined so far, but we have the rock solid definitions for the underlying transport and more standards. So if you're designing products, there's quite a number of OEM suppliers where you can get ready-made SOM boards or even IP for integration into your products, which have all the ST2110, AES67, PTP, and even NMOS in place, so you can build on top of that. On the user side of things, the first IPMX ready products had been introduced at ISE 2020 in Amsterdam by, I believe I mentioned it, AJ Video, Magnica, Matrox, and also Ravenna partner Ross Video has introduced some IPMX ready products. So it's not there yet to take it from there, buy product from a shopping list and just deploy them in the field. But we are coming to this point where more and more IPMX ready products getting available.
Yeah, I'm sure there's going to be some time for the market to broaden and for people to adopt it, but it sounds like it's pretty promising. It sounds like it's got a lot of benefits for the industry overall.
Yeah, and don't forget, this is all originating from the rock solid, already proven stuff, which is being in use in broadcast, and that's where it's really heavily in use.
Well, that's great. Well, thank you so much for your time. I really appreciate you being able to spend some time with us, and that was really a whirlwind presentation. So thank you very much.
Yeah, thank you, Wes. Always appreciate that. Thanks for having me. And if you need any more information, Ames is the place to go to. And hope to see you soon somewhere in the world.
Yeah, hopefully we'll have a chance to get together sometime. And
Right.
maybe we could even do it someplace where we could wear our cool sunglasses.
Ah, that would be
great,
nice.
you
Huh?
know?
All
Yeah, I
right.
really like yours. I'm impressed that you're able to do everything on your computer still wearing those and everything. That's pretty impressive.
Okay, yeah.
That's looking good, and you know, let's hope for a cool summer. You know, none of this 100+ degree weather and things. So.
Right, and then maybe we have a cool down situation on COVID-19, so we're all able to meet maybe even this autumn or latest next year, and then have a regular schedule of shows.
Oh man, I would love that.
Yeah.
Okay, thank you very much.
Okay, thank you, Wes. Goodbye.
Bye bye.